So in this video, we will be talking about inverse matrices and determinants. So we've kind of already said that if I wanted to add two different matrices or subtract them, this is possible if dimensions are the same. So if the dimensions of the two matrices are the same, then it's possible. Same thing, well, kind of the same thing when you multiply two different matrices. So this is also possible if the columns of A equals the rows of B. So if those guys are equal, which is kind of like if you had m by n and n by n, so you basically are looking at the insides just to make sure that they're equal to each other. All right, so now what we really want to think about is what exactly does it mean to divide a matrix? So dividing matrices. I mean, there's really no such thing as dividing matrices, because really what you got to think about is that you can't quite divide a matrix by a matrix. That quite doesn't happen. What instead can happen is that we have to think about what exactly division means. So division means that if I multiply one by the reciprocal of the other, I get basically 1. Okay, I can kind of write it as x times x to the negative 1. That gives me 1. Okay, so basically this is kind of what it means to divide. So when you divide two different things that are the same, it gives you a 1. So what does that mean in matrix world? So we need A times A inverse to equal 1. So in matrix world, we're notice that a 1 is going to be, it cannot possibly be just a number 1, because you remember when you multiply two matrices, you're going to get another matrix out. What that basically means is that you're going to get a matrix, but what kind of matrix do you get? You actually get something called identity matrix. 1 is the identity matrix. And what the identity matrix is, so this is what it looks like as a 2 by 2. So an identity matrix basically has a diagonal of 1s, and then everything else is just a 0. An identity matrix for a 3 by 3 is going to still have a diagonal of 1, and then everything else is zeros. So that's what that means. So in other words, if I want to figure out the inverse of something, or the division of matrices, then I need to make sure that both matrices, matrix A and then A inverse, equal the identity matrix. That's basically what it is. And to kind of showcase that, if I multiply x by 1, notice that I'm going to get x. So let's say, for example, I gave you a matrix 2, 1, 3, and 2. What happens when I multiply this by the identity matrix? So if I take the identity matrix and I multiply this, well, we know how to multiply them. So this is just going to give me 2 times 1 gives me 2, plus 1 times 0 gives me 0. Then the first row with the second column, that's going to give me a 0 plus a 1. Then second row with the first column, it's going to give me a 3 plus a 0. And then second row, second column gives me 0 plus 2. So what this gives me is a 2, a 1, a 3, and a 2. Notice that I get exactly the same matrix as the very beginning. So this works. This identity matrix basically multiplies anything and you get the matrix back. So this is basically what we're gonna do. So if there exists a matrix A inverse such that A inverse equals the identity matrix, which is still the same thing as A inverse A, then A inverse, that's how you say it, A inverse is the inverse of A. Okay, so if I can show this, then I know that that's going to be. Let's do this example. So show that B, which is 1, 1, negative 2, negative 1, is the inverse of A, which is -1, -1, 2, 1. Okay. All right, so now let's go ahead and just show that the multiplication between A and B should equal identity. So this would be sufficient to just say, oh, that's just identity. That's just basically what it is. So I'm going to have -1, -1, 2, and 1 multiplied by B, which is 1, -2, 1, -1. So all I have to show is that this equals identity. So I'm going to multiply these guys out. So you're going to get -1 plus 2. Then first row, second column. It's going to give me +2 plus -2. Then second row, first column, you're going to get -1 plus 1. Then second row, second column, you're going to get 2 minus 1. So you'll see that you get 1, 0, 0, 1. So you get the identity matrix. So that means that this guy is the inverse. And you could have also done it the other way, B times A. You would have still got an identity matrix as well. Okay. The question here is how do we know that that was the inverse? How do we come up with that? So I'll show you what that is. But before we do that is the following. I'm going to say one more thing. So A can only have an inverse if it is invertible. And what it means to be invertible means that this A has to be a square matrix. And what does it mean to be a square matrix? It means that the number of rows is equal to the number of columns. So number of rows equal number of columns. So when we talk about inverses, you can only have an inverse if you have a square matrix. And if it does have an inverse, then we call it invertible. Okay? So there's many different ways that we can know how to find an inverse. I'm going to show you one way, or the way to kind of find the inverse. And then I'm going to show you another way in which we can know whether something will have an inverse or not. So how to find an inverse? How to find a inverse? Now, to find the inverse is the most annoying thing in the world. So the first thing that you got to do, so here's basically the first step. So you're going to take matrix and augment with the identity matrix. Okay, so I'm going to augment this matrix with the identity matrix. So it's going to look something like this. So you're going to write the A matrix there, and then right down the line, you're going to write the identity matrix on the other side. So depending if you have a 2x2 or a 3x3 will depend on what you have over there. The second thing is to find inverse. Turn A into identity matrix. So basically, you have to use row echelon, Gaussian elimination, to reduce this A into an identity matrix. And what's going to happen is that identity matrix is going to also be changing when you're doing row operations, and you're going to end up with A inverse right there. Okay? If it is not possible, so let's say, for example, when you're trying to reduce it, you end up getting a row of zeros, then A is not invertible. So it is not possible for me to inverse this matrix. Okay? And then obviously what you might want to do is you might want to check that A inverse is equal to identity, or that A inverse A equals identity. Okay? So let's go ahead and do this trick. So we're going to do a 2x2. So let's say we do A is equal to -1, -1, 2, and 1. And we want to find A inverse. Okay, so the first step is that we want to augment this. So we're going to say A, which is -1, -1, 2, and 1. And on the other side, we're going to augment it with identity matrix. So that's the identity matrix. So the first thing that I'm going to do is I'm going to try to make the first guy positive. So I'm going to multiply this guy by a -1 to just make it positive. So row 1 is going to be 1, 2, then -1, 0. So then the other one's going to stay the same, -1, 1, 0, 1. So we're going to use Gaussian elimination again. So we need to make this guy into a 0. And the way that we do that, we're going to take, so we're working with row 2. We're going to take row 2 and add it to row 1. That's going to be the easiest way to do it. So the first row is going to stay exactly the same. The second row is going to change. So the second row, this one's going to be a 0, so we did that correctly. Then this guy is going to be 1 plus 2, which is going to give me a 3. Okay. And then you're going to add these other two as well. So 0 plus 1 gives me -1. And then 1 and 0 is going to give me a, oh, wait a minute. I'm missing something. This should be negative. So then this is negative. So then this is -1. This is -1, and this is just going to be 1. Okay, phew. Okay, so now what we're going to do is that we're going to change now this to a positive. So let's try to make this positive. Okay, so that way it's easier. So I'm going to multiply this by a -1. So what's going to happen is you're going to have 1, -2, -1, 0, and then 0, 1, 1, -1. So now what we're going to do is we're going to change this 2, -2 into a 0, because that's going to make it identity matrix. Okay, so what we can do, so we're working with row 1. We're going to use row 2, and probably what we should do is multiply it by 2 first, and row 2, and then add it to row 1. Okay, so then the second row is going to stay the same. And then over here, so when I multiply this by 0, this stays as 1. Multiply this by 2, that's going to stay as a 0. Multiply this one by 2, add the -1. You're going to end up getting a +1. And then same thing here. Multiply this by 2. That's going to give me -2 plus 0. This is going to give me -2. So now what I did is that this guy now is identity. So I made that into an identity. That means the other guy is going to be A inverse. So in this case, A inverse is going to be equal to 1, 1, -2, -1. Okay, and you can check this. You can multiply this to the other one and you can see that it's correct. Now, this is really annoying. So imagine that if you had a 3 by 3. If you had a 3 by 3, so let's say you had a 3 by 3. This is what you got to do. Let's say the 3 by 3 matrix was 3, 2, 1, 1, 0, 1, 2, 0, 2. That means that what you got to do is augment it with this identity matrix. Okay, you got to augment that. And you got to do a couple things. You got to convert this, this, and this to zeros. This, and this to zeros. Convert all of these guys into ones. And then also work with this. And that's a lot of work. So we will do a problem like this via Zoom. So I can show you how to do it on Zoom. What I'm going to test you guys on is basically on determinants though. Okay, so how do we use determinants to help us know if something is invertible? So let's go to the next topic, which is determinants. So determinants, and you kind of already know what determinants are. So determinants basically tells us whether something will be invertible or not. So if the determinant of A is equal to 0, then matrix is not invertible. So that means there's no inverse that exists. If the determinant is not equal to 0, then matrix is invertible. So an inverse does exist. So knowing that an inverse exists, that's basically what that means. Okay, now how do we find determinants? Well, determinants are really easy. If you have a 2 by 2 matrix, let's say you have A, B, C, and D, the determinant, which sometimes we also say the absolute value of the matrix A, is just basically the multiplication of the first two, A times D, minus the multiplication of the off diagonal, which is going to be B and C. Now this looks familiar. Don't you remember the cross product of vectors is basically taking the cross product. So the cross product is basically finding the determinant. So that's for a 2 by 2 matrix. If you had a 3 by 3 case, just to give you a little reminder, I won't do the whole thing, but for the 3 by 3 case, let's say you had A, B, C, D, E, F, G, H, I. Remember that the way that we did it is that we're going to start off by the first row. That's going to be A. And we're going to write the minors, which is basically, imagine that I'm deleting this guy. And the inside is going to be E, F, H, I. Then we're going to subtract the next term, which is B. We're going to ignore what's below it and what's next to it. And then we're going to have D, F, G, I. And then plus C. So this is this next one. Ignore the bottom part and use this as a minor. D, E, G, H. Okay? And then we just continue until we get a number. Okay? So let's do one example. So determine if the following is invertible using determinants. Okay, so here A is equal to 2, 3, negative 1, 0, 2, 4, negative 2, 5, and 6. Okay, so let's figure out if this is going to be invertible. So what you're going to do is find the determinant of this. To find the determinant, remember that determinant of A is equal to, so we're going to start off with 2, and we're going to ignore the bottom parts and the side. It's going to be 2, and then this is the minor, the 2, 4, 5, and 6. That's the first part. Then we're going to do minus, and then do it with a 3. So then this is going to be, ignore the bottom part, so that's going to be 0, 4, negative 2, 6. Then we're going to add it to negative 1. And then we're going to take, ignore the bottom one, so it's going to be 0, 2, negative 2, 5. So it's basically just doing the cross product. So now this guy is going to be 2 times the multiplication of these guys, which is going to be 2 times 6, gives me 12, minus 4 and 5, which gives me 20. I'm going to do minus 3. We're going to multiply 0 and 6. That's going to give me 0. Minus this 4 and negative 2. That's going to give me a negative 8. Then a minus 1, because a positive and a negative give me a negative 1. Then you're going to get 0 and 5, which gives me 0. Minus 2 and negative 4 gives me negative 4. Okay. So then here, you're going to get an 8. And it's going to be negative. Then minus 3 times 8. And then minus 1 times a positive 4. Okay. Now let's go to your calculator. So 2 times negative 8 minus 3 times 8 minus 4. That's going to give me negative 44. So that is the determinant. Notice that the determinant is not equal to 0. And since it's not equal to 0, that means matrix is invertible. So that means that there is an inverse out there that exists. You can find it by doing the augmenting of the identity matrix, but I don't want you to do that because that's a lot of computation. So for the exam, this is what I want you guys, this is how I'm going to be testing you guys on inverses. Okay, if I make you do an inverse, it would be a 2 by 2. Computers now can do inverses much faster than we can, but just note what. But we will do an example on Zoom. I can show you how to do it there.